Yes, so good morning, everybody, and welcome to our Veeam Partner Academy about Veeam Kasten K10, the Kubernetes data protection solution by Veeam. My name is Ruben van Achter, and I am the Business Development Manager for Veeam Tech Data. Now, before we're going to start with the actual presentation given by Timothy, I would like to encourage everybody to make this session as interactive as possible. If you would have any questions during the presentation, feel free to unmute yourself and pose your questions. You can add them in the chat box, of course, or you could wait until the end of the presentation where we provided some time for a Q&A. Now, I think that's the most important thing for the introduction. So whenever you're ready, Timothy, you can start with your presentations.
Okay, so I'll start by sharing the screen. First of all, I know that we have 2 hours, but actually I don't think we will completely need it. So feel free to ask a lot of questions. So there's definitely time for that, because Kasten K10 is actually not a very difficult product, very easy to manage. So, but I'll start by introducing myself. I'm Timothy De Win. I'm actually a solution architect for the Nordics and the Benelux. And you can find me on Twitter at @DeWin if you want to follow me. I've been working for Veeam for almost 10 years. So 1st of October marks my 10 years anniversary at Veeam. And I'm really excited to actually introduce you today to Kasten K10. So why is it called Kasten K10? That's maybe the most important question of all. So if you look at Veeam, traditionally, we have a product called Veeam Backup and Replication. That is still our flagship product. We use that to back up virtual machines, agent for Windows, Linux, and so on. So basically everything you have in a modern data center, we can back up with backup and replication. Until a couple of years ago, I would say we started to hear more and more customers ask us, what about Kubernetes? So in the very first days, I would say, of Kubernetes, we could actually get away by saying, oh, it's all stateless, right? So you don't really need backup for it, right? It's all stateless web servers. But what we noticed gradually a couple of, I would say 2 to 3 years ago, gradually we started seeing more enterprises saying, no, we actually have state in our Kubernetes cluster. We do need a backup solution. Now, what is interesting, if you think about Veeam, the word itself comes from actually VM. So initially we were called VM, but a lot of people were confusing us with VMware. And that's no coincidence. The thing VM literally comes from VM, written VM, but then completely written out. And the idea was, when the company was started, was we're gonna make a software that is really focused on backing up virtual machine workloads. Because what we see traditionally in the market is that companies or backup companies are making a software and they saw virtual machines and they treated it as if they were physical machine. With Veeam, we took a completely different approach. We said we're going to focus on virtual machines, and it turned out a pretty good success because we actually were able to do very fast backup, but also very fast recovery from a single backup. So when we looked at Kubernetes, instead of saying, okay, we're just going to bolt something onto our product like our competitors did in the past, we actually said, okay, we don't know anything about Kubernetes. We don't really have experience with that. We don't really have know-how on how to really back up Kubernetes. I mean, in the past, we actually advised people, okay, there are most of the worker nodes, most of the servers are just running as virtual machines. You can back up those virtual machines. That would be, and we still hear customers say this would be a really bad idea, because backing up a cluster and then just restoring it as virtual machines can completely break your Kubernetes installation. So a couple of years ago, one of our VPs actually went to KubeCon, scoped out the market and saw who's actually here that provides really good backup, really focused for Kubernetes. And it turns out there was a company called Kasten. They have a product called K10. And initially, we decided to work together because there is no conflict, actually. We do the same thing, but for different, I would say, products, right? So Veeam for virtual machines and all the rest, and Kasten K10 really for Kubernetes. So it we were planning on actually working together just to form this big alliance. But as we approached each other more and more, and where we saw we want to integrate both products, we actually decided to acquire them. So this is a process that's already going on for a couple of years. And I'm really excited that we are now also seeing the first integrations happening between Veeam Backup and Replication and Kasten K10. So just to give you that backstory, just to for you to understand why is it called Kasten K10. So the product is K10. The company that builds K10 is Kasten. Basically, they only have one real commercial product that is K10, and we actually bought it and are integrating with it. That's the gist of it. So when you talk about Kubernetes, so I decided to actually do a little Kubernetes for dummies, right? Because we noticed that a lot of people want to jump ahead and say, okay, what can Kasten do for Kubernetes, but do not really understand what Kubernetes is or what it does, right? So this is why I'm going to give you a mini tutorial about Kubernetes. I'm no expert by all means, but I have been playing with it. So I'm just going to dump my knowledge on you. And so you actually understand why it's so important to have Kasten K10 as a focused product and what it actually does. So that's really important. The first time I saw Kasten K10, I really didn't understand anything of the demo just because I didn't grasp Kubernetes enough, right? So first of all, what do containers do? So you cannot say Kubernetes without containers. Well, it's all about application isolation. So in the early days, when we had an Exchange server and a SQL server and a web server, maybe what we did was we installed one application on one physical server. And the reason it's pretty simple, right? If, for example, the SQL server is overloaded, you don't want the Exchange server to suffer. And so what you do is one application, one server to do that easy isolation. Then, of course, we introduced virtualization, like hypervisor, a VMware or a Hyper-V, basically virtualizing the hardware and creating this multiple isolated virtual machines on one physical server. Again, if one application is misbehaving, the hypervisor is responsible for making sure that one application does not impact the other one. Now, with containers, and I'm sure you guys already have seen this, so I'm not going to go too much into the details, but with containers, what you do is you actually do virtualization of the operating system. So instead of creating the isolation at the hardware layer, creating virtual machines, you actually do a virtualization of the kernel. And I put a penguin here because if you think about containers, there are Windows containers, but they are really not so popular at all. I think one of the biggest problems is that they are huge, they are slow, and the community decided that Linux containers make the most sense. Like a basic Windows container will be 2 gigabytes big. A Linux container can be 10 megabytes big. So, and you will see in the story that that makes a lot of sense. So basically at the basic level, a container is basically isolation of the application, but at the kernel level. And again, they are more lightweight. You can run a lot more containers than you can run virtual machines on one physical machine. And the reason being is because you're doing it at a higher level. You don't have to install 100 times Linux. It's just one Linux installation that actually isolates your application. By the way, we think of containers as something magical, but it is nothing more than starting your application and setting security limits on what it can actually do and what it can actually see. So it's nothing magical. It's just an application started up in this limited sandbox. So if you look at the virtual machine, I also wanted to put another perspective because I think a lot of focus, if you think about containers training, a lot of focus is on this application isolation, but I also wanted to put another perspective. If we look at the VM box and we open that box and we see what's in it, surely there is the operating system and there is the applications. That makes sense, right? But what is really important is that in that box, there's also the configuration data. So how should the operating system work? How should the application work? We're not talking about the data itself, but we're talking about how the data is or how the application is configured. Think about the SQL server. So the data sits inside the database, but how the SQL server itself is set up, that is something that sits inside the virtual machine. And then lastly, of course, the application data itself sits in that VM box. So for us to do a backup, it's really easy, right? Because everything sits inside that virtual machine box. We can back up that complete box and we have all the data. If we need to do a restore, we can just bring back that box and we have everything back. And so a lot of people think that it's true for containers, that it's actually the same. We need to really focus on the box itself. And that's not really true, as you will see. So I want you to think about that as well. It's about not only the application and the operating system, but it's also about the configuration data and the actual data of the application that sits inside the box. That box runs on a hypervisor, of course, can be Hyper-V, can be ESXi. And if we think about our data centers, of course, we could have one server that is running ESX or Hyper-V, but in most environments, what you have is you have multiple ESX servers, and then you need some kind of central management. Most people will be familiar with vSphere, with vCenter as being that central management, right? So maybe you have 100 ESX hosts, but you have only one vCenter that manages them, that clusters them, and that makes sure that there is high availability for your application. If we think about containers, it's actually a completely different story. If we look in the box, the only thing that is in the box is the application itself. There is no data, there is no configuration data inside the container. It's only the application. And the actual data for the application, so your SQL database, is also not sitting in the container. So containers are super lightweight because basically they are just the application and all of its dependencies that it needs to run. But if you download a container, you still need to plug in the data, configuration data, and the application data. We'll talk about that later, but that's really important. A container can be extremely lightweight because there is no data inside of it. Again, a container runs somewhere, right? And that is on a container runtime. So if we think about container runtimes, a lot of people will be familiar with something, and I will go back, okay. Something like a Docker, right? Docker is something that can run a single container, and you can run Docker on your laptop or on any server. But of course, one Docker node or one Docker worker node, it's interesting, right? You can run one container on it, but it doesn't give you high availability. So if you want this kind of central management, this kind of high availability, you need something like Kubernetes to do that central management. So probably this is also important to understand the link between Docker and, for example, Kubernetes. You can have multiple servers running Docker, and then you can have one central management server or central data plane that is actually running Kubernetes, and that is managing those Docker nodes or worker nodes as a complete cluster. By the way, this is not 100% true, because if we think about, for example, vSphere, if you think about ESX, if you install ESX, you can actually go to the web GUI of ESX, create virtual machines directly, and you can actually add memory, add CPU, add an ISO, install everything. So you could run ESX standalone, but in reality, you never use that functionality, right? Because you have vSphere, that central management layer. So in reality, you never connect to an ESX host directly. And this was what was happening with Docker as well. Docker has a lot of functionality that you don't really need in day-to-day management in a cluster. With Docker itself, you can actually create containers, you can upload them to a registry. We'll talk about that later. You can build them, you can run them, you can do everything with Docker. But in reality, in a cluster, you only need to be able to run containers. You don't need all that extra functionality. And so what Docker as a company said is, okay, we'll split up the container runtime, that part that runs the actual container, in a project called Containerd. And actually, Containerd is like a Docker Lite that can only run individual containers. And so Kubernetes has actually decided I think like 1 or 2 years ago, that they will not support Docker anymore. So if you go on the internet and you see that Kubernetes doesn't support Docker anymore, what it actually means is that they say, well, you don't need Docker anymore. We can talk directly Containerd. We don't need all that extra overload of functionality. Where is Docker and Docker as a product itself is still useful is that a developer can run it on his laptop, create container images, send them to the cloud, and then actually run them in a Kubernetes cluster where Containerd will just run your containers. So why did containers become popular? And this is a really important question. There's a couple of reasons. The first reason is probably because I think this is one of the most interesting stories that I heard on a podcast and was also very relevant. Developers actually, every time they want to run a new version of an application, in the past, they had to ask the IT guys to create new VMs to run a new version, right? Because you want to run those applications side by side. You don't want to necessarily deploy a new version and instantly kill the old one. So you don't want to upgrade. You want to run them side by side. So developers were asking the IT guys, can you create the new VMs? IT guys, I'm sorry to say, but we are actually guys that are very to ourselves, and we don't want to give out those resources because we all know when you give out a VM, you will never get those resources back, right? When you create a new VM and you give it to somebody, those RAM and CPU resources, they are gone forever. For example, I know we have another product called Veeam Backup for Office 365. And that actually sometimes sits at the end user team. And I remember a POC where we actually wanted to test Veeam Backup for Office 365. The guy had to request VM resources from the IT team. And I said, can we do the POC next week? And he said, no, we're an enterprise. I have to request the VM. It's going to take 1 month or so to get that VM deployed, which is completely madness. But imagine now you're a developer, you have a new version of your application and you want to run it, you want to test it out. It's going to take 1 month to get a new VM. So developers started to look at something new, and something new that is containers. If you can ask, for example, the IT team to create some virtual machines that will act as worker nodes that will run that container runtime, and then you create a Kubernetes cluster, then you can actually talk to that Kubernetes cluster and deploy new applications on the fly without having to recreate new virtual machines, because you do the abstraction at the higher layer. But there's something else. So first of all, creating an application is one thing, but you also want a way to create the application and then deploy it in production. And this is where I would say Kubernetes and containers come into play. What the developer can do is he can build this application on even on his laptop with Docker, but also just in a build farm, actually package that up, build what is called a container image, send it over to a registry, and then deploy it on premises in a couple of seconds. To give you an idea, I always compare this to how your mobile phone works, right? If you think about your laptop, when you need to install an application, you have to go to the website, find the application, go to this complex wizard, takes a lot of time, right? But with your mobile phone, it's a completely different story. You go to the Play Store, you select the application that you want, you click install, it's one click of a button, it's just one command, install, that's all. There's no extra questions and so on. Your phone actually downloads a complete image from the Play Store and runs it on your mobile phone. And this is the same thing here. Really, a container, you can only run a container from an image, right? So again, the same story here as for your mobile app. The developer builds that container image, sends it over to a registry, basically the Play Store for containers. And then when you want to run the application, somebody in production can actually say, okay, I want to run this container. This complete image is downloaded and is started on this container runtime. So this is something that is extremely fast in containers world, because literally, for example, I can build an application, send it over to a public registry and have it running in Amazon in a couple of minutes. In fact, the developers have a process they call CI/CD, often referred to as CI/CD, but in full, it's continuous integration, continuous development, where if they, for example, checking code in GitHub, GitHub Actions will see that new code, will automatically create a container, build a container, push it in the registry. And then, for example, there's applications in continuous development like Argos, which will automatically download the container and run it in a cluster. So you can imagine that now, instead of waiting 30 days for the IT guys to actually create a container, to create a VM and run the application, now a developer can make a code change, and literally a couple of minutes later, they have a version of their application running in, for example, their dev cluster. So it's extremely fast development, and it's easy to see why the developers have actually switched to this framework, right? Because now they can actually develop and test in minutes instead of hours. So, okay, we talked about the container, why it's so useful, why everybody loves it, right? But we have one issue left, right? If we think about the container, there's only that application inside, right? So how do we actually configure that application? If you are a developer, for example, that has created, I don't know, a SQL database, some kind of SQL database, you've created that image and you send that to a public registry. Now all of your end users want to use it. They have to have a way to kind of configure that SQL database, right? Maybe they want to configure the password. Maybe they want to create a database at startup and so on. How is that actually working? Well, this is where Kubernetes brings a lot of value. So you have your application, and when Kubernetes starts the application, you can actually decide to inject a couple of things. First of all, there are concepts in Kubernetes that you can define, which is called a config map. It is a secret. These are basically YAML files that you actually give to Kubernetes. Kubernetes stores it in some kind of JSON format inside of its database. And every time a container starts, it will inject this config map and the secrets. Again, what is a config map? Could be the SQL database configuration. What is a secret? A secret could be a password, could also be, for example, a TLS certificate for a web server. The point being here is that this is actually injected when the application is started. So if you have, for example, an update to your application, you can actually just remove the complete container. You can remove the complete image, the complete container, and just run a new version, and Kubernetes will re-inject the config map and the secret. So actually, a container itself doesn't hold any data, and you can easily upgrade it because all the data sits in Kubernetes. Same thing for storage. If we think about, for example, that SQL database, it will probably produce some real storage or some real data, right? So you don't create a database just to create a database. You create it to hold some real data for your production environment. So I always like to say Kubernetes has a concept of persistent volumes. They are like the USB drives for containers. A persistent volume in Kubernetes is something that you can request. You can say, okay, I want to have a disk of 50 gigabyte, and then there's a system, for example, CSI storage, that will actually create automatically that volume, and that volume can then be connected to your container. Again, it's like a USB drive for a container in that sense that you want to update the application, you just remove the application container, you download the newest version, you run the application, and this persistent volume together with the config map and the secrets are plugged into that container. Now, why is this really important? Why am I stressing so much about this? Why am I putting this on a slide? It's really important to see that there's actually no real data inside the container. So when you're new to containers or when customers coming from an infrastructure field, coming from a VM world, they come to us and they say, yeah, how do you protect the container? I actually say to them, we don't actually protect the container because there's nothing really useful inside the container. In the container, there's just the application that's downloaded from the registry, but the actual data sits inside Kubernetes. You have your config map, you have your secrets, you have your persistent volumes, and those are live injected. So when we think about container protection, we really have to focus on Kubernetes, on backing up all that data that is stored in Kubernetes, all that data that is stored on persistent volumes. And this is actually what Kasten K10 does, actually is focusing on that part of the story. Again, defined by, managed by, injected by Kubernetes inside that container. So Lastly, or actually, I think I have one more slide on the Kubernetes for Dummies. When I started this journey to Kubernetes, what I found the most interesting part is kubectl. And kubectl is the command line that all the developers are running to talk to Kubernetes, right? And so if you've ever heard somebody talk about Kubernetes, they will always manage kubectl and how it's amazing and fantastic. So why is it actually fantastic? Because kubectl is a single command and it works almost the same for all Kubernetes installations. So a developer, once they know how Kubernetes works, once they know how kubectl works, they can actually work with Kubernetes clusters defined in AWS, in Azure, on OpenShift. OpenShift is a little bit different because Red Hat has actually modified Kubernetes a little bit, extending it, and we actually have to make some kind of adjustment to our product to actually manage OpenShift. But also, for example, VMware, Tanzu, they all interact with the same way. So you can, or the developer can interact with them in the same way. Think about how powerful this is. If I want to learn how virtual machines are managed, I have to learn VMware on premises. But if I want to go to Azure, I have to learn how Azure actually works. If I want to go to AWS and I want to run virtual machines there, I have to learn how AWS works. But it is not true for Kubernetes. If you spin up a Kubernetes AKS or EKS cluster, surely the initial setup is specific to the cloud provider. But once it's spin up, you can actually use kubectl to communicate with that cluster. And it's the same for all of these platforms. So really, this is really fantastic because now you can say, I'm running an application on premises, tomorrow it's running in AWS, and tomorrow it's running in Azure, because Kubernetes is actually creating that abstraction layer. The developer itself doesn't have to know about how the underlying platform works. The only thing that he knows is kubectl and how Kubernetes works. How it's implemented underneath, it's really not important for the developer. And again, that's one of the, I think, most powerful parts of Kubernetes is that Kubernetes acts like a abstraction layer, and therefore often is also referred to as cloud native, right? Because you have one tool to manage all of those applications and all of those clouds. Now, if we think about a traditional application, one application in a virtual machine, we often also talk about monolithic applications, right? One application that does everything. And so one of the biggest disadvantages is this: as your application grows, it becomes very unmaintainable because now all the developers are working on the same code. One guy making a mistake might impact a team of 1,000 developers or 200 developers. And so this is really the only way to work with virtual machines, right? Because if you would want to make a lot of smaller applications, you would have to request a lot of separate virtual machines, and that would really be unmanageable, right? Think about the fact that you have to have, imagine if you want to split that up in smaller application, now you require, let's say, 10 virtual machines. You have to install Linux 10 times. That's going to consume memory, CPU. So traditionally, we were making this big monolithic applications. Now, because you have the power of containers, which are extremely lightweight, again, it's only running the application. You don't have to have that overhead of the, let's say, operating system. What we see in the container world is a concept of microservices. And that basically means instead of making this big application, you split it up in smaller applications that give a service to each other. And from the outside world, it looks like one big application, but internally you can split it up in this very small micro applications that work together to form one big application. Now, why would you do that? Actually, there is a saying that Jeff Bezos himself from Amazon says that you should have teams that are smaller than 2 pizzas. What does that mean? You should be able to feed the complete team in a meeting with 2 pizzas. If you cannot feed a team with 2 pizzas, then your team is too big and it should be split up. And so this is where microservices come into play, right? You might have 200 developers in your company, but now you can actually separate them in smaller teams. You can say this one is, for example, responsible for I would say, user management. This one is responsible for content streaming, this one for inventory. I don't know. Let's think about Amazon, for example. One is doing your registration as an end user, holding your data of your addresses and so on, so membership. One is maybe doing the catalog service. One is maybe doing the promotion service. One is maybe doing the search engine and so on. All of these teams now can build their specific application and run them in a container. That gives them also freedom to actually use, for example, different databases. So one team could use, for example, a Microsoft SQL server, one could use a Postgres server, one could use some NoSQL database and so on. Every team can do what they want in their island. And actually, Kubernetes has a lot of concepts to actually help with that. So first of all, they have namespaces. Namespaces are, I would say, very similar almost to resource pools in vSphere, where you can actually group containers together, and where actually one team can work in one namespace and the other team can work in another namespace. And by working in these separate namespaces, they are unique. So for example, one team could make a container that is called web. The other team could also create a container that is web, but they are unique because they are actually running in that namespace. They could both have a SQL server with the exact same naming, but just running in different namespaces. So they are not really security bubbles, but they are a way to make your containers unique and to kind of isolate them a bit in this environment. What is also interesting is Kubernetes has extra definitions, extra things that you can define. For example, you can define a service. And as a service, when you define a service, it's actually like creating mini load balancers inside of Kubernetes. These mini load balancers will, if you, for example, have a SQL cluster, you have 3 nodes or 4 nodes or 5 nodes, and the web server needs to connect to the SQL server. How will it know where to send the data to? Well, what you do in Kubernetes is you define a service and you say, I want this data to be routed to all the SQL containers that have this specific label. So it's kind of like a mini load balancer inside your Kubernetes environment. Another thing, what is really cool about Kubernetes and services is that when you create a service, Kubernetes most of the time, I would say 99% of the time, has a built-in DNS server. Okay, so when you create a service, this automatically creates a SQL record inside the cluster. And now actually, okay, maybe this is really important to know, but when you create a container in Kubernetes, it just gets any random IP. So by creating actually this DNS inside the cluster, a web server can actually say, I want to connect to the SQL service. Really, literally from the web service, you could ping to SQL in this example, and it will resolve to that mini load balancer. So now actually you are completely, the IP space is completely virtualized. When a developer makes an application, he will actually say, I want to connect to, for example, SQL, or that's configured via the config map, but he doesn't care about IPs. In fact, you could have an application that is developed on premises, has one IP range, go to the cloud as another IP range. Doesn't really matter because Kubernetes works with these mini load balancers that automatically create DNS records. What is also interesting is that these DNS records are unique inside the namespace. But for example, if the web server wants to contact to another application in another namespace, for example, the web from the right wants to connect to the SQL server here, he could actually say, okay, I want to connect to SQL.namespace, and actually the internal DNS will actually resolve that. So you can see actually Kubernetes, again, abstracting everything from the underneath kind of infrastructure that is out there. IPs are not relevant by using this kind of service setup. And then, of course, maybe you have an application that runs inside your cluster and you want to access it from the outside, then you need to define an ingress. An ingress actually defines how you can access your application. Point being here is that, that's actually the point here is that now, if you didn't get any of this, what you should really take away from this is that you have your container, it's only running the application, and how these applications actually work, how they work together, that's all defined in Kubernetes. You have your config maps, you have your secrets that are injected inside the container that actually configure the application. You have a persistent volume. Again, that's like the USB drive that actually has the data, the actual application data that you connect to the container. You have a service that actually defines how applications can interact with each other. And you have an ingress that actually defines, for example, how an application can be accessed from outside the cluster. So all of these concepts are defined at the Kubernetes level. And when we think about kind of the backup of this, is we have to really focus on these kind of concepts. We have to think about backing up the persistent volumes, but also what is called these resources that sit in Kubernetes. We have to back them up because they actually describe how the application should work inside your cluster. Actual persistent volumes or states of, before people were saying, oh, okay, Kubernetes is only holding stateless data. It's just web services that do not really produce data, right? They are actually just web servers that have some application logic, but the actual data sits in a database that is still running inside a virtual machine. This can be true. And if you are new to a project, if you are talking to a customer about Kubernetes, it's really important to also ask the customer, is it a stateless environment, or is it stateful? Is all the state running in the Kubernetes, or is there still data outside the cluster? So if you think about that, if you go to a customer that wants to back up Kubernetes, make sure that you also ask them, is the actual data in the cluster or out the cluster? Because if it's outside the cluster, then you might back it up with Veeam Backup and Replication. But if you think about the restore, you have to make sure that you also restore the data, the database itself, and also the web front-end server that might be in Kubernetes. What we've seen is in the last couple of years, again, more and more customers and clusters are not only running stateless applications. There's more database sitting in Kubernetes. And the reason is very simple. You think about how easy it is to set up, for example, a database in Kubernetes. Literally takes, for example, one command, one Helm chart that you can install, and your application is up and running in a couple of minutes. You don't have to go to this complex installation wizard. It's very easy. You can just refer to a public registry. You don't have to download an ISO and install it. No, you can just say, I want to run this application, and it will be automatically pulled from the public registry. And so this is the reason why more and more people are actually shifting workloads to Kubernetes. And also, of course, if you have stateful data, you have to actually back it up. Again, some more data. I have to remind you that in the right corner, you see that these statistics are from 2020. So actually, by now, we expect that most clusters are actually running some stateful application. And again, what are those applications? Mostly databases and message queues. Message queues are kind of systems for these microservices to communicate with each other in an efficient way. Now, what does Kasten K10 do? So this is really important. We have switched from the Kubernetes for Dummies, and we are now looking into what Kasten K10 does. When you think about Veeam backup and replication, what we do is we do backup and recovery, fast recovery. We allow you to do a backup and restore it to another ESX cluster if you would, or to another vSphere cluster if you want that. We can actually convert from Hyper-V to VMware and the other way around. So we also provide application mobility. And we actually also do disaster recovery, right? Funnily enough, this is also the core values for Kasten K10. They do backup and recovery of, I would say, Kubernetes cloud native applications, right? Because we are not talking about backing up containers. We are backing up cloud native application and everything that sits inside Kubernetes. I didn't talk about everything that is in Kubernetes because there's even much more, but we back up cloud native, basically everything that sits in Kubernetes, all the persistent data, and we allow you to recover that in a very fast way. Application mobility, again, something that Kasten K10 does is they allow you to back up from one kind of Kubernetes distribution and restore it to another distribution, right? I saw in our internal chat today a guy posting how to migrate from OpenShift to Tanzu, or another guy discussing how to migrate from Tanzu to, for example, EKS that is in AWS. So we really give you that tool that allows you to migrate from one platform to another, also, for example, between cluster versions. Again, same thing as we do with Veeam Backup and Replication, but applied to that cloud native applications. And disaster recovery, again, this is something you can do with Veeam Backup and Replication, but Kasten K10 also allows you to do this. Is, for example, backup to a central S3 bucket, and then actually have a Kasten K10 sitting ready in a DR location, importing actually what is being backed up and ready to fail over in case of, for example, if your main data center burns down, you can actually start a restore process and have your application running. We can do this cross-cloud, like I said before, so think about how powerful this is. For me, this was the eureka moment when I actually backed up an application that was running in EKS in Amazon, backed it up, and then restored it to an AKS cluster. And this restoring process took like 1 minute to get a web server with a database back up and running in AKS. And for me, it was a really eureka moment, because I was thinking, what if you need to do this with a virtual machine? What if you need to back up a virtual machine from AWS and you need to restore it to Azure? This is something we can do actually with Veeam Backup and Replication, but we need to go through this conversion process. And because Kubernetes actually creates that abstraction layer, you don't need to do that conversion process, because it's all the same stuff, right? It's all Kubernetes. There are minor conversions that we have to do, and actually Kasten K10 has some built-in tools to do minor edits to the configuration files en masse in batch, so that it goes very smooth and very fast. But it's so cool to see that. For me, it was the coolest thing to see. I have an application running in Amazon, I back it up, and now I can just flow it over in Azure to Azure in a couple of minutes. That's really what cloud native is all about, I would say. Now, Kasten K10, what is actually one of the core focuses that Kasten K10 does, and what makes a difference? So there are open source tools out there that you can use, but the biggest problem with them is that they are actually command line and really built for the developers. And what we see is that if you think about Kubernetes clusters, there's actually a big problem, or a big issue with the teams that are managing those Kubernetes clusters. On the one hand, you have your developers and your DevOps. They are all about applications. They all care about development, but they have never really cared about backup, because in the past, when they were running in virtual machines, these virtual machines were just being backed up by the infrastructure team, and they never had to really care about backup, right? Because everything is inside the box. The infrastructure guys back up that box, and when there is a problem, they can restore the whole box, all of the data, all of the configuration data, the application, and so on, in a single pass. So they never cared about backup, and they still don't really understand the importance of backup. They never had to deal with ransomware attacks. They never really had to deal with, for example, policies, right? Because we still have company policies that says you need to keep your data for maybe 10 years or whatever, your specific company policies. They never had to deal with that. From another side, we have the infrastructure guys. These guys, basically it's us, right? We've been creating VMs in the past. We've been managing vSphere clusters. We've been doing backup. We know how backup works. We know why it's important. We've had to deal with, for example, the ransomware attacks. We had to deal with, for example, corruption and so on. We had to deal with somebody by accident deleting a virtual machine and all of its data. So we know all about the importance of backup. But the problem is we don't know anything about Kubernetes. Kubernetes is a very abstract new world. It's kubectl, right? So it's command line. That's what the developers love, but that's not necessarily what the infrastructure guys are used to. And so Kasten K10 actually approached this and said, we're gonna make a tool that actually works for both of these teams. So Kasten K10 is a cloud native application. it runs inside your cluster. It actually extends Kubernetes. So if you want to configure it with the CLI, with kubectl, you can just do that. Everything you configure, you can do via kubectl, because we basically just extend Kubernetes as kind of an operator inside your Kubernetes cluster. From the other perspective, Kasten K10 also thought about the infrastructure guy, and they actually made a nice web GUI. You can log on to this web GUI, and once you're logged on, it's really easy to understand how you can back up an application that sits inside the Kubernetes cluster. It will show you all the application. You can define this kind of policies. You can configure your backup locations and so on. It's really easy with this kind of web GUI. So it caters to both needs. You have the DevOps guys that want to do kubectl, okay. From another perspective, if they don't want to manage the backup and it falls to the infrastructure guys, you can just use Kasten, you can use the web GUI, and you can just do a backup and a recovery from that nice web UI. Also, it has a dark mode option if that is something that you really want. Finally, ransomware protection is also something that we see more and more happening to Kubernetes cluster. For us as infrastructure guys, it's really nothing new, right? We've been dealing with that. I can tell you, for example, inside Veeam Backup or Veeam as a company, for Veeam Backup on an application, inside our support team, we have a separate team, which is called a SWAT team. And the only thing they do is ransomware attacks. So you would be surprised how many of the current calls that come in the Veeam support that are about ransomware. It's huge, because backup is that last line of defense, right? When everything is broken and you still have some backups on an immutable media like a tape, or you have it in an object storage with the object lock enabled, or you have some kind of immutable repository set up, Linux immutable repository, then backup is that last line of defense against those hackers. And what we see is that in Kubernetes clusters, this is becoming more and more often an issue. You get hackers that get into the environment and that can actually delete those persistent volumes, because that's the issue. Once you introduce actual persistent data in the cluster, there's also a danger of losing that data. And so we see more and more that this is becoming an issue. One of the issues is, for example, there is not enough knowledge about how to set up a secure Kubernetes environment. A lot of people go for that next finish install, I would say kubeadmin approach, right? Because it's a very complex topic and they just want to have a running cluster. So over privileges, let's say, something very common. There's a lot of new K8 releases. The cycle is every 3 months. There's a new version of K8. So it's really hard to keep up with the newest releases. And of course, the applications, the attacks are getting more and more sophisticated. So Kasten K10 actually solves these kind of issues. Again, we are a cloud native application. So to install Kasten, you don't need separate hardware. It is just an application that runs on top of Kubernetes inside the same platform as you run your other cloud native application. In fact, if you have a running Kubernetes cluster and you want to run Kasten K10, it's literally 2 lines of code. It's a Helm chart. So you first have to add the Helm repository, and then you can just say Helm install K10. It takes around 5 minutes, I would say even less, to get a Kasten K10 installation going. So if you think it's a problem that we have, if you have, for example, 10 clusters and it's going to take a lot of time to install Kasten K10 in each and every cluster, no, it's just a matter of copy pasting those 2 commands and you have Kasten K10 running. By the way, Helm charts are a very popular way to install cloud native applications inside of Kubernetes. So if you've never heard of that, it's kind of like a easy install wizard to install not only the container, but also everything around it that we discussed, the config map, secrets, and so on, predefined by, for example, the application vendor. One thing that is important, if you are a customer with multiple clusters and you want to have one single dashboard, you can actually install Kasten in each and every cluster, but you can link them together in what we call a multi-cluster dashboard, so that you still get a central overview, get one UI, and from that one UI, you can actually configure all the individual clusters. So if you're worried about central management, again, Kasten K10 has that multi-cluster setup. So again, Kasten K10 sits inside your Kubernetes platform, and what can it do? So in the first stage, it can do what is called a backup. For me, it's not really a backup, but Kasten K10 calls it a backup. What we basically do is we download all the configuration data from Kubernetes and store it in our own catalog service. And we will actually create a snapshot on the persistent volumes. So we will actually ask if it's a CSI driver, we will actually ask the CSI driver to create a snapshot. Otherwise, for certain let's say storage vendors for Kubernetes, we still have a direct integration, but I would say CSI is the way forward, is what all the vendors are using now, but just use the CSI driver to create a snapshot on those persistent volumes. Of course, this is what Kasten calls a backup. I don't really call it a backup because everything still sits inside of your Kubernetes cluster. So if your Kubernetes cluster goes down, you don't really have a backup. So Kasten, of course, has something to externalize that backup, and that is what is called an export. That's what I would call a real backup. So you take the snapshot from the persistent volume, you take the data, and you can send it over to the object storage, or you can send it over to NFS, for example. We can take the Kubernetes data, we have it in our catalog service, but we can also push it through to the object storage and to NFS. And that, of course, is a real backup when you externalize the data to object storage or to NFS. So could be S3, could also be Azure Blob Storage, for example, can also be the Google object storage. What is interesting for S3, we also have object locking going on, making your data immutable. And again, this is important for ransomware attacks. If you have persistent data in your cluster, you actually need to get the data in the object storage. And then with this object lock, you can make sure that the data cannot be deleted. So even if an attacker would actually get access to the Kasten K10 console, they actually are unable to delete the backups because they are locked. And by the way, this is one of the, officially it was never communicated like this, even internally, but I have a suspicion this is actually the doing of Veeam, right? Because we've built this object lock, S3 object lock functionality in Veeam Backup and Replication. And when we acquired Kasten K10, half a year later, this was one of the first features that came out after the acquisition. So clearly some kind of input from our development team, that positive feedback loop going into the Kasten K10 team. Now, finally, there is actually a third option, fairly recent, and that is Veeam Backup and Replication. So you can actually back up to Veeam Backup and Replication, but the use case is limited. And I'm going to be very upfront here. This is not a sales pitch here. It is also a technical session. So I'm going to tell you what it actually means. So we can actually back up to Veeam Backup and Replication in the case that you are using a vSphere CSI driver. This means that your worker nodes, the container runtimes, actually, the nodes that are running the containers, are virtual machines, and the persistent volumes are basically VMDKs that are automatically deployed or created by the vSphere CSI driver. So basically, your persistent volume sits on top of VMDKs, and actually the vSphere CSI driver will connect that VMDK to the right worker node where your container is running. If your container is running all of a sudden on another worker node, then it's a vSphere CSI task to actually connect it to the correct worker node and to the container. Now, in a vSphere CSI scenario, the actual data sits in a VMDK. And how to back up VMDKs, that's something we know very well at Veeam Backup and at Veeam, especially with Veeam Backup and Replication. We've been doing that for multiple years. And so in this scenario, what actually happens is Kasten K10 will actually instruct Veeam Backup and Replication to back up those VMDKs in the most efficient way, right? We've built this knowledge for 10 years. And so basically Kasten delegates the task of backing up the disk to Backup and Replication. It's really important because that means that actually only let's say, applications that use vSphere CSI drivers can use this integration. Only when your worker nodes are running in virtual machines using vSphere CSI, we can have that integration today. And the reason why we chose it, again, is we have the knowledge to do very fast backup. We also have specific knowledge to do restores. So for example, we can do an instant disk recovery with Veeam Backup and Replication also for this kind of first class, this kind of disks for containers, right? For these persistent volumes. We can also do file level recovery from Veeam Backup and Replication because again, we know how to back up VMDKs and we can actually read the data and show you the individual files, something that you cannot do directly in custom. Again, we've talked about this a lot, but this, for example, is what a cloud native application would look like, right? You have an ingress, the way how an end user can access your application. You have these services that define how individual containers can talk to each other. We have pods, by the way, inside Kubernetes. We don't talk about containers all that much. We talk about pods. And a pod, in most cases, is a single container. So in most cases, there's one pod. If you look at a pod, it's one container. It's one security bubble in which an application runs. So why does Kubernetes make this abstraction of a pod? Why doesn't it just call it a container? Well, there is something special about a pod. A pod can also have multiple containers or multiple applications running in the same security boundary. So a pod could have one container, which is the most common case, but could also have multiple containers running in the same security boundary. And I'll explain you why that is in a very easy example. Imagine that you want to collect logs of all your applications running in your Kubernetes environment, right? Because your containers are actually only running your application. That application might create logs. But again, we talked about updates. You just remove the container and you download the new version and then you run it. That means that if you would do that, your logs are gone as well. And so you want to have this kind of central log management going on. What you could do is ask the developer to add your logging mechanism, your logging software inside their software. And so they could make a bundle, one image of their application with your kind of logging application, make that bundle and send it up as an image to the registry. But that would become cumbersome, right? Because they have one customer that uses this log platform, another one uses that log platform, and so on. So instead, what Kubernetes does is says, okay, you can have a concept of a pod where you can run your main application, and then you can have what is called sidecar containers. These are containers that are not actually doing any real business logic, but they are kind of supporting containers for the main container runner and that pod. And that actually is very interesting because now you can actually say, okay, I want to inject my logging software in each and every pod. It has, when you inject it in the pod, it sits in the security boundary. It has the same access as the main application. It can read the logs, collect them, and send them to a central location for data. And so we all also use this concept of a pod in our advantage. For example, there are use cases where we do a sidecar injection of a container to back up the data, for example. So we can actually inject one of our applications inside a pod in the main application and download or back up the data of the container. Long story short, in most cases, a pod is a container with some extra benefit that you can actually inject containers to do some extra services for the main application. Okay, we have pod, we discussed about services. So we have our microservice application that exists out of multiple applications, multiple pods. They can talk to each other with services. For example, one pod has a backend database. It has a configuration map that tells it where to talk to, and then it has the user name and password stored in the secret. We have one application that has persistent volume claim and so on. All of that defines our application. Again, Kubernetes is that abstraction layer. Maybe this sounds very complex, so I will just show you all of these concepts in reality, and then it will become a bit more clear. So here I have my stock application, and you can see we are out of socket licenses, but you can still buy full licenses. What I will do actually is I will actually buy 10 licenses maybe to show you that it's a dynamic application. Okay, So it's bought, and you can see we have now 8,990 full licenses. So you can actually see that it is actually a live application. I will also run my backup job quickly. I will explain this a bit later, but I'm just going to run it so that the backup is being run and it's being done. So let's look under the hood of this application. So if I look at kubectl get node, I have one physical server running in my cluster. So it's one cluster node, one physical server running containers. If I look at my namespaces, my cloud native applications, you will see there is Kasten running in a namespace as a cloud native application, and we have this stock demo application running. What kind of containers are we running in my namespace stock demo? You will see that there is the web server. It's running as a deployment. That's another Kubernetes definition. Let's just assume that this is the web server, and this is actually a Postgres database server. So you can actually see inside my namespace, there are two pods, two containers running, one database and one web server. How can they actually talk to each other? Well, there is a service definition. So you can actually see there's a service definition for the database called StockDB PostgreSQL, and it does the internal routing. That means that my web server can actually talk to StockDB PostgreSQL, and it will actually reply. So again, there's a kind of a DNS server, core DNS server running in the Kubernetes cluster. By defining this cluster IP, there will be automatic load balancing being happening over my PostgreSQL servers if it was multiple pods. But it will also create that DNS record. So now my web server can just connect to that PostgreSQL, and it doesn't have to care about this random IPs. So it could be any IP. As a developer, you don't really care. You define your application, you create a service, and then you know that from your web server, you can just connect to that DNS record. And then to access my application, there is an ingress. So you can see this defines that /stock needs to, if I actually look at the configuration file of that ingress, will actually tell me that everything that is /stock needs to be redirected to the actual web service. You can see how elegant you can define everything in this kind of Kubernetes objects. And you can actually take these objects, run them on my on-premise environment. I can run them on AKS, I can run them on EKS. Doesn't matter because it's all abstracted by Kubernetes. For example, also, we talked about config maps. Let me see if I have any config map in my stock demo. I will see that there's actually a certificate for this, but there's also a configuration file that probably defines how, let me just look at it. Yeah, it just applies some of the configuration data for the database and so on. So that's all defined there. And again, secrets and so on. And what is the main gist here is that your application is defined in Kubernetes, not in the container itself. So let's look at Kasten K10 as a product. So again, we have here a couple of namespaces. Let me show it to you. So we have stock demo, we have OpenEBS, that's something else, and we have Kasten IO. So if we go to Kasten, to the web GUI, and I go to the dashboard, it will actually discover all these applications, all of these namespaces. So you can see here OpenEBS, the default namespace, and stock demo. So if you want to create another application, you can just create a new namespace. Let's say tech data. And then if we actually do that, we'll actually see that popping up here. So that's how easy it is. Then once you've done that, you can actually create a policy. So again, it's all GUI driven. If you wanted to create a policy, just click create policy, and then you can create a backup job. So the first thing, like I said, we can create a snapshot. So a real backup, Kasten refers to it as a backup, but for me, it's just a snapshot. You can just say how frequent you want to back up, hourly, daily, weekly, whatever. And then you can say what the retention is. You can say this amount of hourly snapshots, weekly, monthly, and so on. Very similar how you would do a backup job for Veeam Backup on application. Now, these are not really backups, right? These are just snapshots inside the cluster. So if you want to make a real backup, you have to do this snapshot export. So when we click snapshot export, I can actually back up to a location profile. What is a location profile? You can actually see it's an S3 bucket. Think about the location profile. I'll show you that later in the configuration as well, but think about that as a repository. So if you're coming from Veeam Backup on Replication, the location profile is basically a repository. In my case, it's an S3 bucket where I can back up to. I can define the same retention or another retention, that's all fine. You can do more fine-grained selection, not going to go into details. Do we want to back up everything or do we want to exclude stuff? So for example, we talked about secrets. There might be username and password in there. Maybe you don't want to back up that secret. You want to redefine it. That's fine. But most of the cases, you just want to back up all of the definitions. What we should do before or after the backup, that's also something you can do. And then canister, we're not going to talk too much about canister today because it's a whole other kind of topic. But what canister is, it's kind of, if you want to go one step further, if you are running a database, you can actually use canister to make not only crash consistent backups, but also to make application consistent backups. If you are familiar with Veeam Backup on Application, canister would be two things actually. So in Veeam Backup on Application, you have something called application-aware image processing, allowing us to make consistent backups for virtual machines without installing an agent. That is something canister can do as well with certain applications. Or we also have plugins for enterprise applications like Oracle RMAN, SAP HANA backend. We have those enterprise applications. You can use those integrations to do a dump of the database to Veeam Backup on Application. This is also something that canister can do. So these two actions that we know in Veeam Backup on Application, you can actually do with canister, making basically consistent backups. You can create the backup policy if you want to share the YAML file. So you can actually see we are creating it all in the GUI, but this is actually the complete YAML file that will be created inside of the Kubernetes cluster. If you have a developer and he wants to configure their own backups, you can actually create it in the GUI and then send them the YAML file as kind of inspiration, I would say. So if I create policy, then a backup policy will be created. So we have the default backup, we have our stock demo backup. I just did a backup of the stock demo because I also want to show a restore. And by the way, again, we've done it all via the GUI, but if you look at here, so I'm just going to do the policy in the complete policy. So you can actually see that the policy we just created is here. So everything can be done via the GUI. Everything can be done by the CLI. If there are real DevOps people in this call, how is the security done? Well, we actually just create cluster roles. So if I do the cluster roles, yeah, I don't need to do everything, but you can see we create cluster roles here. We also create regular roles. And you can do cluster role bindings or role bindings to give access to individual developers, for example, so that they can manage their backups, but only for their specific namespace, for example. So this is the way we do security. We just extend the Kubernetes method of doing security. We just expand on that, and you can use the same way or the same configuration. Again, that's more for the developer guys. Question we often get: how does security work? Well, basically, ask yourself, how do we do security? How we do RBAC today for Kubernetes clusters? And we can just extend on that. So we have a policy. I've run that manually before, so we can actually go and see if it's there. You can actually see policy run. Sorry, that's the automatic backup of itself. Let's click on the stock demo backup. And you can actually see the initial backup being done inside the cluster. And if we look at what is being backed up, of course, the persistent volume for my database, so where the actual database sits, but also everything we've discussed. I know it's becoming boring, but it's really important for you guys to understand that all of the configuration sits inside of Kubernetes, and therefore we need to back up the secrets, the config maps, the services, everything, the ingresses, service account. We didn't talk about this. I have middleware, some custom definitions, deployment, stateful set, all of these definitions that are being done by the developers inside Kubernetes. All of that is being backed up. And so we did a backup, we exported it to S3. Okay, great. Now let's pretend we have a attack. So let's just say get namespace. We have the stock demo application here, and let's I'll make it a little smaller. Again, our application is live now. You can see that 8999 or 8990, that is in the backup. Let's just, for the fun of it, buy some extra so that number changes. Or let's change this one so it's obvious. At 500, so it's not 100,000. After a restore, it should be 100,000 again. Okay, done. Okay, so this is not 100,000 anymore, and this is not 9,000 anymore. Okay, great. Now let's delete the application. So we have a hacker. There is somebody in our environment. They delete the namespace stock demo. Okay. So what is the impact? Our application is down, right? Should become page not found. Oh my God, super crucial for Veeam, right? We can no longer sell licenses. That is our core business. Whether you like it or not, we sell licenses. That is our main job. We don't have apples or bananas to sell. We only have licenses to sell. So now our stock application is done. Our complete image is broken, or a complete store is broken. We can no longer sell licenses. There's already negative PR saying that Veeam is not up and running. So we want to recover very quickly. Fortunately, we actually made a backup. So we can go to applications, and you will see that the application is no longer there, right? Because it has been removed. But if we go to removed application, we can actually see here this stock demo application. So we'll click restore, and we'll select the backup of today. And I'm just gonna do this one here, and I'm just gonna restore it back to the original location. By the way, maybe before I do that, you can actually restore to another namespace if you would like to do that. There are some actions that you can do. This one, apply transformations, is the most interesting one, I would say. Why is that? If you would restore from AKS to EKS, there are minor differences in, for example, the way the storage is stored. So for example, in AKS, you might have an SSD disk, that's the storage class it's called. And then in Amazon, they are talking about GP2 or something like this. So these details are stored in something called a storage class. Maybe you want to change that to match actually the storage classes that you have in AWS. Well, you can actually batch do that with something what we call a transform. So if I would be restoring from one cloud to the other, I can actually mass update all the configuration files that need adjusting to match the other cloud vendor. We don't need to do that, right? Because we are actually restoring to the same cluster, but just know that we have actually prepared for doing this cross-cloud restores. What am I going to restore? Well, sometimes I get the question, can we do granular restores? Sure, you can. So if you only want to restore the volume, you can do that. In our case, everything is deleted, so we want to do a complete restore. But you can choose to restore only the configuration file or only the database, or the data volume, the persistent volume. You can actually have that granularity if you want to do that. It's also important to know that there's a lot of our competitors that only focus on the persistent volumes. And that's also problematic, right? Because in this scenario, they would be able to restore only the volume, but they don't have any of the configuration, which is so important to actually get our containers back up and running. So I'll click the restore button here. and our application is still down. That's normal. So we'll look at the Kubernetes cluster. And if I look at the namespaces, we'll see that actually the namespace is recreated 0 seconds ago. And that means that the restore process is actually happening. So I'll look at the containers that are, or the pods that are in that stock demo. They are not any yet, so I'll just put this awaiting. And what you actually say is happening live is Kasten K10 is creating certain containers to restore the data. So it's first trying to restore the persistent volume. And once that persistent volume is restored, all the other containers are actually created. So it makes sense, right? First, the data is restored, and then the actual application is restored. So we can actually go back. And we can actually see that happening here. So you can actually see the restore is going on. I have to say that it's actually slower. Maybe it's because the demo gods want me to be a bit slow today. Normally it's even faster, but it is running, so it is working. And you can actually see the restores going on. So let's see, actually, while we are waiting for this, we can also see the persistent volume in that stock demo. Let me just the other way around, get persistent volume. You can actually see the persistent volume is being restored here. And if you look at the containers now, I guess most of them are up. So the web server is up and running, and the database server is not running yet. It's actually being started. So that's why Kubernetes is saying it's running. But you see this 0 of 1, it means that the container itself is not started, or the application is in the process of starting. Yeah, now it's running. So our application should be restored. And if we go back here, we'll see that before the backup, we changed this number here, then we did the backup, and that matches the reality. After the backup, we changed this number to something lower than 100,000, but you can see that it's restored to the point where it took the backup. You can see in a couple of minutes, we've restored successfully a web server and a SQL server or Postgres server, and then the interaction between those all defined in Kubernetes. So think about how powerful this is, right? Now you have an application, it's down, and in a minute, it's completely restored. And could be in the same cluster, but could be also outside the cluster. So that's backup and restore in a nutshell in Kasten K10. I will show you a couple small things still. If we go to settings, we can see the locations. Again, remember that I said the locations are kind of the repositories. If you are used to Veeam backup and replication, so it could be Amazon S3, could be NFS, that special use case for Veeam backup and replication. If you click Amazon S3, you can also see that immutable backup mechanism that is there. What else? It can backup itself, so you can do a backup of Kasten K10. And then maybe licenses. I do want to show you licenses. You can actually see that my trial license has expired. So when you install Kasten K10, it will generate 2 licenses, a trial license for 500 nodes. So 500 worker nodes, that would be the equivalent, if you think about a virtual infrastructure, to 500 ESX hosts. So here you have 500 work nodes that are in trial automatically for 30 days. That has actually expired. Interesting enough, at Veeam, we have for Veeam backup and replication, the community edition. Kasten also has this, it's called a starter license, and they are quite generous because you get 5 worker nodes. So basically not 5 containers, but 5 like servers, could be physical or virtual machines that run containers that you can back up unlimited. So there's no limitations. So if you are just getting started and you only have, let's say, 1 or 2 servers, if you have a cluster of 3, let's say, container D host worker nodes, you can actually get away with a single starter license. So that's it. You don't even need to request a trial key. You can just download the software or use Helm to install it, and it will automatically generate these licenses. Finally, again, Kasten K10 canister blueprints. We didn't talk about this, but basically allows you to do consistent backups for certain application. Let me just jump to the docs and show you this. So if we look at the applications that we support, logical backups, that is kind of the way of doing the dumps. So MySQL, Postgres, and so on would be very similar to those who know Veeam Backup and Replication, like the enterprise applications, like Oracle RMAN plugins or SAP HANA backend. So some examples, and application consistent backup. So we have some for the most common ones that we see in Kubernetes, MongoDB, Postgres, and so on. There's also a unique feature where they can actually back up RDS databases. So when you define a database outside the cluster in Amazon in an RDS database, we can also back up that as well. What is interesting, why is it called Canister? Because it's also open source. So this part of the application, Canister, to make consistent backups, that is actually completely open source, and you can actually extend it with your own blueprints, basically. Finally, installing, I've said this, but I just want to show you guys to install it, for example, in AWS. You see it's a single Helm command. Okay, you need to first add the repository. That's not showing here, but you add the repository, one command, and then you add this command, and basically in 5 minutes you have Kasten K10 running. So if you have a Kubernetes cluster, really easy to trial. That's it actually on the Kasten part. I think I covered everything. There's maybe one more thing that we get asked frequently. Is there kind of a Veeam one for Kasten K10, some monitoring and reporting? Actually, Kasten K10 takes this cloud native approach, right? So what they actually do is they run Prometheus and Grafana, and they can generate automatic reports showing you what is the data usage of the solution. So you can actually monitor that from here. What is even more interesting, so you have this nice graphics here, but if you want to customize it, you can build your own Grafana dashboard. So we actually allow you to create your own dashboards in Grafana if that's something that you want to do, or you can even access the Prometheus data itself. So basically very open, very easy, automatically installed, but if you want to integrate it in your existing Prometheus installation, you can do that as well. So I've talked about the demo. Again, open, we support all the major cloud vendors, also support on-premises. OpenShift and Rancher is what we see the most popular. VMware is pushing really hard with Tanzu. In all honesty, most customers really running in production, they are running OpenShift. Tanzu is really trying to catch up with the market here. Again, we have integration with the specific applications to do consistent backups with Canister. We didn't go in too much details, but hopefully you can see that we have some integration. And in terms of storage infrastructure, before it was really relevant because we had to talk to the cloud providers themselves to create consistent data or consistent backups of the persistent volumes. Nowadays, I would say the market is really shifting to CSI drivers. So any CSI driver that can create persistent volumes and can create snapshots will probably work with Kasten K10. We have a complete list in our documentations of what we have tested and support. But for example, the one that I use in my demo is not listed there, and it just works fine out of the box. We try to focus on the ones that are popular in production in those customer environments. Finally, next version of Kasten K10 and backup and replication, I would say it's more about backup and replication version 12. What you will be able to do is you will be able to add the Kasten installation inside backup and replication. So that means if you have multiple Kasten installations, you can add them to backup and replication, and you have that single pane of glass. So today we have an integration with backup and replication only for clusters that use vSphere CSI drivers. But starting from version 12, you will be able to do central management and monitoring from backup and replication. Yeah, that's actually it. I was actually thinking it would be problematic to talk 2 hours, but apparently it's not. So hopefully you guys learned something new. I didn't get any questions, which I think is a pity, but hopefully you guys still learned something new. You feel like more confident. If you want to try out the software, again, you can contact us, but you can also just download and install it in the cluster. Literally only takes 2 commands and you have a cluster running. Super easy. But if you feel like you need some assistance, please feel free to contact us and we can see how we can help you, assist you with setting up those initial installations.
Thanks, Timothy, for the great presentation and the demo. I have to admit, your animations were impressive.
Thank you.
Now, before I end the webinar right now, I have to show one more thing. Let's see if I can still share my screen.
Yeah.
Somehow I unhosted myself. Yes, you'll have to make me co-host again, Timothy.
Okay, let me just go there and then I'll say more and you are making co-host. I'll do that. And you should be co-host now.
It's okay. Okay.
Yeah, there you go.
Okay. Yes, so the last thing that I wanted to show you is the Kasten K10 deal registration incentive. So let's say you have some potential Kasten K10 deals on the radar, then yeah, starting now until the end of the year, December 30th, you can earn an additional 10% discount when you register a Kasten K10 deal. So yeah, depending on the partner level you have or are, you can get up to a total discount of 42%. So that includes the standard discounts, the deal registration, net new logo, and the additional 10% for the Kasten promotion. So if you want to see all the terms and conditions, you can check them out at the Pro Partner portal. Under the tab promotions, but after the webinar, I will also send an email including the link to the recording of this webinar, the slides of Timothy, of course, and some additional information about this deal registration incentive. So that's about it. If there are no additional questions, then I think we can end our webinar here.
Okay.
Okay.
I see only a comment in the question, so I'm gonna say that is answered live. But thank you for the positive feedback, Dominique.
Thank you.
Okay. Have a nice day then.
Have a nice day.
Bye.